Hello everyone, this is heading 10. Let's learn chapter 6.1, Fundamental Trig Identities. In this lesson, we will learn 3 objectives. You must memorize the identities we have learned from chapter 5. So pause the video and memorize all of these trig identities. We have learned all of these in chapter 5. Also, you must memorize the algebra rules. You learned these in your algebra class. And so pause the video. You memorize all of these rules. You must also memorize another one is conjugate rules, which is A parentheses A plus B times A minus B equals A squared minus B squared. And they are equal. If I provide you A squared minus B squared, you need to show us A plus B times A minus B. So for example, if I have sine squared x minus 1. So use conjugate relationship. You need to have sine x plus 1 and times sine x minus 1. Okay, let's continue. Simplify an expression. Use quotient and reciprocal identities. Write the final form with no fractions. So the way we are simplify an expression is we convert all the trig functions into the x, sine x and cosine x. So let's see the first one. Secant x squared times cotangent t. Cotangent x, cosine x. So convert all of these into cosine and sine. So secant use the reciprocal rule. Secant equals cosine x, the reciprocal of cosine x. That's 1 over cosine x. Don't forget the squared. And the cotangent x equals converted to the cosine sine. This is a quotient rule. So cosine x over sine x. And cosine x is cosine x. And look, the bottom one cosine x, the top one cosine x, and here is squared. I can cancel out them. If you want to do that step by step, you can do that equals 1 over cosine squared x times cosine x. So this is cosine x. I can multiply it on the numerator part, cosine x. Bottom one is sine x. Cosine squared canceled out equals 1 over sine x. This is a simplified form. If you don't want to have the fraction, you can make this one into what? The cosecant x, because cosecant x is a reciprocal of sine x. So all of this complex expression is simplified by us, and we get the result is cosecant x. Let's see this one. Next one. So convert everything into cosine sine, and only this one is not the cosine sine. So we use the quotient rule, make it into cosine sine expression. So bring down the first term. Cosine x over 1 plus sine theta. Oh, this time it's theta, it's not x. Plus tangent x equals sine theta over cosine theta. If I want to, the first term and second term has the same denominator. So what should I do? The first one need to multiply by cosine theta. And the second term, bottom and the top, need to multiply by 1 plus sine theta. That means cosine theta. We will use a lot of algebras to compute it. 1 plus sine theta. I need to have this common denominator. That means the bottom one need to multiply by cosine theta. Cosine theta, because this term is 1. So if I want to create the denominator is 1 plus sine x times cosine x, I need to use this term multiplied by cosine theta divided by cosine theta. Okay. Then plus sine theta over cosine theta times, I need to have the same denominator, 1 plus sine theta times cosine. I have cosine here. I need to multiply by 1 plus sine theta. 1 plus sine theta. It doesn't matter if you don't have the parentheses. Okay, continue to simplify this. No. Sorry. Why it happened? Let's see. Let me open it again. Where are we? Okay, we're here. All right, simplify this. So, 1 missed. Okay, the denominator is 1 plus sine theta times cosine theta. The numerator is cosine theta squared plus, if I want to put the 1 plus sine theta first, I can switch the position. 1 plus sine theta times cosine theta. The top is sine theta times 1 plus sine theta. Since they have the same denominator, I can add the numerator together. Oh, this one equals, oh no. This is my first time to try use the PDF to record the video. Okay. So I hope this time it won't make me trouble. So the denominator is 1 plus sine theta times cosine theta. And the numerator part, cosine theta squared plus, so I want to distribute it. That's sine theta plus sine theta squared. And do you still remember the Pythagorean theorem? Cosine theta squared plus sine theta squared equals 1. So let's continue here. So this one plus this one is 1. 1 plus sine theta And then bottom is 1 plus sine theta cosine theta. So this one canceled out because they are the same terms. I got 1 over cosine theta. If I don't want to have the fraction in the expression, I can convert it to its reciprocal, that's secant theta. So the answer for this question is secant theta. Okay, let's continue. Factoring. So if here they ask you to factor it, that means the expression, you need to factor it by using the algebra. Let's see. Do you feel this is very familiar about? So conjugate formula, a squared minus b squared equals a plus b, a minus b, right? So this one equals tangent t plus 1, tangent t minus 1. Bottom is, so this term has sine t, this term has sine t. I can pull out the sine t, that's coefficient, and tangent t plus 1. Let's see. So here has tangent t plus 1, here has tangent t plus 1, canceled out. So I have tangent t minus 1 and sine t. We're not done because I haven't converted to the cosine sine. So tangent t equals, I need more space. Tangent t equals sine t over cosine t minus 1 divided by sine t. Can I say if I divided something, means I multiply by its reciprocal? That means I times 1 over sine t. And then I can distribute the 1 over sine t in it. So I distribute it. That means sine t times cosine t times 1 over sine t minus 1 times this is 1 over sine t. And then cancel the sine t. I got 1 over cosine t minus 1 over sine t. If I don't like the fractions, I can convert it to its reciprocal. So cosine t is 1 over cosine t, that's secant t. And 1 over sine t, that's cosecant t. So this is a solution of the question. Let's move on to next part. Verify trigonometric identities. So these are steps you can use. First, start from one side. Final goal is another side. The previous examples, they just let you simplify the expression. But now you need to prove the equation. For example, if I have some identities like if I have tangent square root of theta plus 1 equals secant theta squared. So you need to prove this side equal this side. That means you can start from this, and then you got the expression like secant square theta. We're proving this. Actually, you can also start from both. If it's the expression or the equation is very complex, you can start from left-hand side. you got one expression with x and with cosine and sine expression, and then it's not equal to the right hand side, but you can start from the right hand side again, and then your right hand side equals something like with cosine and sine, and then, for example, this is number 1, number 2, and number 1 equals number 2. So this one is proved, or you already verified the equation. So these are the example. Let's see what you can use. You can use trig identities like reciprocals, quotient rules, Pythagorean theorem, even or odd. That's the table we just mentioned at the beginning of this video. You can also use algebra and the right expression in terms of sine and cosine. That's the idea. We simplify the trig expressions. Let's see next one. Verify this one. Cosine negative x times tangent negative x divided by sine x equals negative 1. So this one, do you still remember the even odd function things? So the top one, we can convert it to the cosine x. So let me write. This is left hand side. This, the top one, use the even odd identity. This one is cosine x, because cosine is even. Tangent is odd. That means pull out the negative sign outside equals tangent x. Since they are multiplication, so I can pull out the negative sign in front here to here. Okay, the bottom one is positive, sine x. And let's continue. Convert tangent into sine and cosine expression. Keep the negative sign in front. Actually, we don't need the parentheses. Cosine x times tangent x equals sine x over cosine x divided by sine x. So the cosine x and cosine x cancel out. Right now we have negative sine x over sine x. This one is negative 1. So if I have more space, I will write the conclusion that left hand side equals right hand side equals negative 1. So we verified this equation. Okay, let's continue to see next one. Verify this expression. You can start from left hand side, because usually I like to start from the left hand side. Left hand side. Since this one, they are a fraction, and this side is not a fraction, so I want to convert it. I want to make them together into one term, and then simplify the expression to make this terms. So let's do it. This one minus this one. If they have the same denominator, I can do the subtraction. So how to make the same denominator? The first one, 1 minus cosine x. Need to multiply the same denominator. That's upside down, all multiply by 1 plus cosine x. 1 plus cosine x. Minus this one. 1 over 1 plus cosine x. Multiplied by, create the same denominator. I need to multiply this part. upside down, that's 1 minus cosine x. 1 minus cosine x equals, the bottom one is 1 minus cosine x plus 1 plus cosine x. Do you still remember the conjugate function? That's a minus plus b times minus b equals a squared minus b squared. Even I switch the position, I put the a minus b in front. That means a minus b, a plus b. I still get a squared minus b squared. That means this expression equals 1 minus cosine squared of cosine x squared. And the top one is 1 plus cosine x. And minus, so multiply these two terms together, I got 1 minus cosine squared of x. And then the top part is 1 minus cosine x. And then add them up, do the subtraction. 1, actually, do you still remember sine x squared plus cosine x squared equals 1? That means 1 minus cosine x squared equals sine x. So the bottom one, I can just simplify it. So the bottom one, 1 minus cosine x squared equals sine x squared. The top part, 1 plus cosine x minus 1, and then here change the sign, cosine x. Do you know why? Because here, like an parentheses, distribute the negative sign here is minus 1. Distribute this one here is plus. So I plus cosine x. So this one, bottom one is still sine x squared. And the top one, 1 and 1 cancelled out. Cosine x plus cosine x is 2 times cosine x. And this one is 2 times, wow, we are getting closer. It's 2 here. Okay, cosine over sine x squared. So we have learned that cotangent is cosine over sine. So cosine x over sine x, and continue. Here is a sine x squared. I need to multiply sine x, and then 2 times cotangent x times the reciprocal of sine x, that's cosecant. So left hand side equals right hand side. That means we verified it. Okay, let's see conjugate. I mentioned about this expression before. So let's see the verification. Verify the equation is an identity. That means we can start from left-hand side, and then I got left-hand side. You see, maybe you see it's so scary, but I'm sure you can do it. Okay, let's start from the left-hand side. Equals, so this one, 1 minus sine t, 1 plus sine t. Use the conjugate formula. That means the bottom one need a conjugate. 1 plus sine t need to multiply by 1 minus sine t. 1 minus sine t. And the top one is 1 minus sine t. Then the bottom is 1 minus, that means 1 minus sine t squared. And the top one is 1 minus sine t squared. because you have sine 1 minus sine t times 1 minus sine t. And then bottom one is cosine t squared. Remember that the conjugate function. The sine x squared plus cosine x squared equals 1. So 1 minus sine t squared is cosine t squared. Okay, the top one is 1 minus sine t. We're almost there. Why? Because top one, bottom one, they both have squared. I can pull out the square outside. That means 1 minus sine t over cosine t. And let's move on. Because the expression on the right-hand side, it has the square outside. That means we're getting close. This one equals. So I can split it into two parts because if I have 1 plus 2 over 8, that's equal 1 over 8 plus 2 over 8, right? I can split it into two parts. So 1 over cosine t minus sine t over cosine t squared. If I have space, I can continue to write. I have no space, write down here. 1 over cosine t, that's the second. That's the reciprocal identities. Second t minus sine over cosine is tangent t squared. So left-hand side equals right-hand side. We verify. Okay, let's continue. This one, in algebra, you have learned the log functions and you know the properties and definitions of this. And in this section, we're going to use a lot of this one and this one. So if they have the same base is this one's b and b. So log b xy equals, I can split the xy into log b x plus log b y. And Rn, I can write it down like log, the base is e. Since base is e, I just write ln. I don't need to say the base is e. And this one, ln is also satisfied these, all of these, from 1 to 7. Let's see, verify this equation. Let's start from the left-hand side because I like to do from left-hand side. If you feel you are good at starting from the right-hand side, you can do that. Left-hand side equals ln, the absolute value of sine x plus ln, absolute value of secant x. So I can copy down this ln, absolute value of sine x plus ln, absolute value of secant x, and they all have the same ln. That means I can add them together. And look at here. So right now I have two terms. They have the same base. I can convert it to one term. That means this one equals the absolute value of sine x times absolute value of secant x. Okay, secant x And do you still remember secant is what trig functions reciprocal? That's cosine. So sine x times, since they are all absolute value, I can multiply them together. That's 1 over cosine x. We're getting closer to the result. So this one equals ln sine x over cosine x. That's tangent. Ln absolute value tangent x. So left hand side equals right hand side. Verified the equation. You can write more detailed information. You can say this expression or this identities is verified, or we verified the equation. Okay, let's continue verifying from each side. If the equation is very complex, we can start from both sides. Is this the last one? No. Okay. Is the example? Okay, let's remember convert them into sine and cosine. So left hand side equals sine x over 1 minus. This is fraction. We don't like fraction. We need to convert it to an expression without the denominator. So this one I'd like to times its conjugate, which is 1 minus sine x. So the top must multiply by 1 minus sine x. And then I got 1 minus, this is sine x squared. And the top part is sine x times 1 sine x. And this one is denominator is cosine squared of x. And the top one is sine x minus sine squared of x. I can continue to simplify this, but I'd like to stop, or I can continue to split it into two parts, because this one is not simplify the expression. This one is proof left-hand side equal right-hand side. So it doesn't matter the expression here is very complex, because we just want to express left-hand side equal right-hand side. So split it, the same denominator. So sine x over cosine x squared minus sine x sine x squared over cosine x squared. Sine over cosine is tangent, so tangent squared of x. And I'd like to start from the right hand side. Right hand side is actually I don't need this step because this is tangent. I'd like to stop here because I just want to have the expression has only sine and cosine. If I have tangent, bring me more troubles. So let's do the right hand side. If I see the expression only have the sine and cosine, so the second minus 1 and the cotangent square of square x. And this one, so let's see. Cosecant is 1 over sine x minus 1. And the bottom one, cotangent x is cosine x over sine x squared. It's cosine x over sine x squared. And then if I want to move the denominator to the top, I can flip it or times the reciprocal. That means 1 over sine x minus 1 times sine x over cosine x squared, and distribute this in the first term, first expression. So distribute this. That's 1 over sine x times sine x squared over cosine x squared, because I can distribute the 2 here and here, minus sine x over cosine x squared. And then sine x and sine x canceled out. Only have one sine x left on the top. Bottom one is cosine x. Oh, cosine x squared. Minus, actually, this one, I distribute the 2, the power. I mean, sine x squared over cosine x squared. And then, wow, we're almost there. Look, they have same denominator. The cosine x squared. The top is sine x minus sine x squared. Okay, now left hand side equals right hand side. Verified. So that's the way you verify the identity from both sides. Since the expression seems very hard, you can do it from both sides. Convert them into the sine x and cosine x expression, and then let them right hand side equal left hand side. You got you are proved this identity. Okay, next one, algebraic to trig expression. So read the question. Example is write the square root of x squared plus 9 as a function of theta, where theta is between 0 and 2 over pi. I think I made a mistake here. It's pi over 2. It should be pi over 2 means the first quadrant. Do you still remember? The first quadrant is 0 to pi over 2. And then continue to read. By making the substitution x equals 3 times tangent theta. This one is very easy. Just plug in the x equals 3 times tangent theta in the expression, and then simplify that. So since we know x equals 3 times tangent theta, the expression square root of x squared plus 9 equals, plug it in, 3 times tangent theta plus 9 squared. And then distribute the square power, the squared. It's 9 times tangent theta squared plus 9. And then pull out the 9 because the coefficient 9 can be pulled out. So 9 outside, tangent theta squared plus 1. Do you still remember that? We have learned that so I can express it like this. 9 times secant theta squared. More space. And since 9 is 3 squared, so this one equals plus or minus 3 times secant theta. And it's positive or negative. Since they provide us the information, make it better looking. Is pi over 2. Since theta is between 0 and pi over 2 is in the first quadrant, that means all trig functions are positive. That means secant theta is positive. So this one is only equals to positive 3 secant theta. That's the last question of chapter 6.1. If you have any question, please let me know. Okay, let me stop recording.